In this video, I want to go over how to perform a global optimization with Nastran Solution 200. Just a few moments ago, I demonstrated how to perform a very simple optimization with Nastran of a composite laminate. We are going to use the same example for this global optimization tutorial. So before I get started, just in case you are a professional engineer, if you want to learn more about global optimization, if you want training on Solution 200, if you have any general questions, you're welcome to contact me at this email address, and I will be more than glad to contact you with an answer. Now, if you are a student or professional engineer and you would like access to the Nastran Solution 200 web app, you can also contact me at this email address, and I will get back to you. Now let's go through the process on how to perform a global optimization. So here, let me take a few moments to minimize all of my windows that I have on the screen. Right before I started this video, I performed a very simple example of the same composite laminate. I found that a good opportunity to then switch gears to talk about global optimization. So just bear with me while I delete my old files. Now to start off, let's go to the web app. So here we are at the web app. You're going to need the solution for this previous example. So let's go to the user's guide. Let's scroll down to size optimization tutorials, and let's go ahead and look for the starting files for this tutorial. So here, let me go ahead and download this zip file. Let me extract the contents. And so this is our work from a previous example. So let's go ahead and now take a step back and open the size tutorial. So here we are going to load the previously done example. And so here I've already gone in and specified all the design variables, all of my constraints and objectives. So this is complete. If you run this in Nastran, it's going to give you an optimized composite laminate. Now, to perform global optimization, go to settings, and here in the bottom left hand corner, mark the checkbox for perform global optimization. Then go to the exporter, and then click on this green button to download a new package. We'll go ahead and open this package. And then inside of that folder, we'll go ahead and start Nastran to perform this global optimization. The web app will open. We have a status page that's going to track each local optimization that's performed. And then at the very end, we're going to end up with our global optimization solution. So let me go back and talk about the original example. Here, we can see that when we first did this one example, we had a weight of 1.6 units of weight, and our optimized model had a weight of 1.04 units of weight. Our layup was previously composed of 85 and 60 degree plies. Our optimized layup was composed of 90 and 0 degree plies. Our thickness went from 0.01 and it went to 0.0065. Our plies were initially experiencing failure, but then by the end, the optimized model had plies that were satisfying our failure criteria. Now, the question for this global optimization we are performing: can we find a better solution than 1.04 units of weight? And here, let's go ahead and see where the global optimization is at. Here, we are currently performing our fourth local optimization. In a few moments, the web app will automatically display our new results. And from that, we can determine if we have a new optimized model. So I think at this point, I'll go ahead and pause the video here, and then I'll come back once this is finished. So the global optimization has finished. The results are automatically uploaded for me. So now let's quickly review what has happened here. The first message says that the global solution is local optimization sample number 4. So here if we look at 4, the new objective, the new weight, the global solution is 1 or 0.15982. In the previous video, our supposed solution was 1.04. That's what we had in our previous video. This would be corresponding to sample 0, 1.0421. If we look at the design variables, you see that I had 90-degree plies and 0-degree plies, and my thickness was previously 0.00652, and that's what we have, 90 and 0 degrees and 0.0065. Now, the Global Optimizer has found that there is actually a better solution. Sample 4 was the one that had the better solution, and the new global weight, the best weight that could be found was 0.15982, which is a substantial difference in the weight. Here, let's go ahead and show sample 0 and sample 4. Here we see that instead of having 90-degree plies, we should be having 0-degree plies. Instead of the 0-degree plies, we should have 5-degree plies. So here, let me see if I can briefly show what the new solution would be. So here, maybe the global optimization solution. So this was, I believe, 0.15. And here, instead of that, I should have 0, 0. And here, I'm just using what's displayed to me in the plotter a moment ago. So this, according to the new solution, should be my actual layup. So here, 0.15982. My layup is now composed of 0-degree plies and 5-degree plies, and my new thickness is actually 0.001. And then here, let's make sure that our design is feasible. So here, we have a negative normalized constraint value, and this indicates that the final design is feasible. Negative means that the design constraints are being satisfied. So here, plies are okay. So there we have it. In a previous tutorial, the best the optimizer was able to do was get at a new composite laminate that had 1.04 units of weight. With this new global solution, it found a better design, one that has 0.159 units of weight. It actually told us what the new layup and the new thickness was. So there you have it. That's how you perform a global optimization with Nastran Solution 200.